Circle here, whose circumference is 18 pi. So if we were to measure all the way around the circle, we would get 18 pi. And we also have a central angle here. So this is the center of the circle. And this central angle that I'm about to draw has a measure of 10 degrees. So this angle right over here is 10 degrees. And what I'm curious about is the length of the arc that subtends that central angle. So what is the length of what I just did in magenta? And one way to think about it, or actually maybe the way to think about it, is that the ratio of this arc length to the entire circumference, let me write this down, arc length to the entire circumference should be the same as the ratio of the central angle, so the central angle, to the total number of angles if you were to go all the way around the circle, so to 360 degrees. So let's just think about that. We know the circumference is 18 pi, so we know the circumference is 18 pi. We're looking for the arc length. I'm just going to call that A for arc length. That's what we're going to try to solve for. We know that the central angle is 10 degrees, so you have 10 degrees over 360 degrees, over 360. So we could simplify this by multiplying both sides by 18 pi, multiply both sides by 18 pi, and we get that our arc length is equal to, well, 10 over 360 is the same thing as 1 over 36. So it's equal to 1 over 36 times 18 pi, which is just, so it's 18 pi over 36, which is the same thing as pi over 2. So this arc right over here is going to be pi over 2, whatever units we're talking about, long. Now let's think about another scenario. Let's imagine another, or the same circle. So it's the same circle here.
Our circle. Download and take your music offline for whichever path you choose. Just download and pull up your playlists to keep the tunes flowing from one adventure to the next. Get 1 month of Spotify Premium
still 18 pi.
Tap the
circumference is still 18 pi. There are people having a conference behind me or something. That's why you might hear those mumbling voices. But this circumference is also 18 pi. So this is also 18 pi. But now I'm going to make the central angle, I'm going to make it an obtuse angle. So the central angle now, so let's say we were to start right over here. This is one side of the angle. I'm going to go and make a 350 degree angle. So I'm going to go all the way around like that. So this right over here is a 350 degree angle. And now I'm curious about this arc that subtends this really huge angle. So now I want to figure out this arc length. So all of this, I want to figure out this arc length, the arc that subtends this really obtuse angle right over here. Well, same exact logic. The ratio between our arc length A and the circumference of the entire circle, 18 pi, should be the same as the ratio between our central angle that the arc subtends, so 350, over the total number of degrees in a circle, over 360. So multiply both sides by 18 pi, we get A is equal to, let's see, this is 35 times 18 over 36 pi. So this is 350 divided by 360 is 35 over 36. So this is 35 times 18 times pi over 36. Well, both 36 and 18 are divisible by 18, so let's divide them both by 18. And so we are left with 35 over 2 pi, or we could even say, let me just write it that way, 35 pi over 2, or if you wanted to write it as a decimal, this would be 17.5 pi. Now, does this make sense? This right over here, this other arc length, when our central angle was 10 degrees, this had an arc length of 0.5 pi. So when you add these two together, this arc length and this arc length, 0.5 plus 17.5, you get to 18 pi, which was the circumference, which makes complete sense because if you add these angles, 10 degrees and 350 degrees, you get 360 degrees in a circle. We have a circle here whose circumference is 18 pi. So if we were to measure all the way around the circle, we would get 18 pi. And we also have a central angle here. So this is the center of the circle. A circle with area 81 pi has a sector with a 350-degree central angle. So this whole sector right over here that's shaded in this kind of pale orange yellowish color, that has a 350-degree central angle. So you see the central angle is a very large angle. It's going all the way around like that. And they ask us, what is the area of the sector? So we just need to realize that the ratio between the area of the sector, the ratio between the area of the sector and the total area of the circle. And they tell us what the total area is. It's 81 pi. And 81 pi is going to be equal to the ratio of its central angle, which is 350 degrees, over the total number of degrees in a circle, over 360. So the area of the sector over the total area is equal to the degrees of the central angle over the total degrees in a circle. And then we just can solve for area of the sector by multiplying both sides by 81 pi. 81 pi, 81 pi. So these cancel out. 350 divided by 360 is 35 over 36. And so our area, our sector area is equal to, see in the numerator, we have 35 times, instead of 81, I'm just going to write that as, let's see, that's going to be 9 times 9 pi. And the denominator I have 36. Well, that's the same thing as 9 times 4. And so we can divide the numerator and the denominator both by 9. And so we are left with 35 times 9. And neither of these are divisible by 4, so that's about as simplified as we can get it. So let's think about what 35 times 9 is. 35 times 9. It's going to be 350 minus 35, which would be 315, I guess. 315. Did I do that right? Yeah, it's going to be 270 plus 45, which is 315 pi over 4. 315 pi over 4 is the area of the sector.
No signal? No problem. With Premium, you can open up a new world of listening possibilities. Download and play what you want to hear wherever you go offline. And with ad-free music listening, it's easier to stay in the zone without audio interruptions. Get 1 month of Premium free. Hit the banner to learn more.